The next one is characteristics of CE configuration. The common emitter configuration, here the emitter is going to be the common terminal for both input and output, and then the output is going to be taken from collector and emitter, and the input is going to be applied between base and emitter. Then the common emitter configuration produces the highest current and power gain of all the three bipolar transistor configurations. This is mainly because of the input impedance is low as it is connected to your forward bias PN junction, while the output impedance is high as it is taken from your reverse bias PN junction. The circuit diagram is shown here, where you can able to see the emitter is going to be common, that is base and emitter is going to be common for the input signal, and similarly CE is going to be common for the output signal. And the equations here, the emitter current is given as IE equal to IC plus IB, as the load resistance is connected in series with the collector. The output current gain of the common emitter transistor is quite lost as it is a ratio of IC by IB. A transistor's current gain is given beta, and as the emitter current for a common emitter configuration is defined as IE equal to IC plus IB. The ratio of IC by IE is called alpha. The value of alpha will always be less than unit. Here the electrical relationship between the three currents IB, IC and IE is determined by the physical construction of the transistor itself. Therefore, any small change in the base current will result in a much larger change in the collector current. For example, the small changes in the current flowing in the base will thus control the current in the emitter collector circuit. For example, beta has a value between 20 and 200 for most general purpose transistor. So, if a transistor has a beta value of say 100, then one electron will flow from the base terminal for every 100 electrons flowing between the emitter collector terminal. So, by combining the expressions for both alpha and beta, a mathematical relationship between these parameters and therefore the current gain of the transistor can be given as the equation is given in the next slide, where IC is the current flowing into the collector terminal, and IB is the current flowing into the base terminal, and IE is the current flowing out of the emitter. Alpha is equal to IC by IE and beta equal to IC by IB. Therefore, IC equal to alpha IE, which is equal to beta IB, and therefore by simplifying we can able to write alpha in terms of beta and beta in terms of alpha. The summary of CE, that is common emitter configuration. This type of bipolar transistor configuration has a greater input impedance, current and power gain than that of the common base configuration, but its voltage gain is much lower. The common emitter configuration is an inverting amplifier circuit. This means that the resulting output signal has a 180-degree phase shift with regards to the input voltage signal.